Hello and welcome to Delta College Impact. I'm Roger Waller, your host for today's program. I think you're in for a shock or maybe a charge, but we can say that today's program is going to be awfully electric as we're going to be talking about the Delta College Electronics program. And joining me on the first half of the show, we have Dwayne Wright. Dwayne is our electronics instructor, and joining Dwayne is Luis Mendez, one of our students here in the electronics program. And so I said it's going to be shocking, Dwayne, so let's start off with a bang and talk a little bit about the electronics program and what's involved in the Delta College Electronics program.
Okay, the Delta College Electronics program starts off with a basic core program of electronics, and this basic core program is geared to take you to a multitude of different technologies. The common areas which all areas of electronics would study is placed first, and then the students then are at liberty to go in any direction that they choose to follow. In the actual training that we have here at the college, one of our areas of study would be following from the core program into repair of home-type electronics equipment, such as VCRs, television sets, amplifiers, radios, and etc. Another area that we go into is actually into the microcomputer repair area and upgrading and maintenance of those computers.
And I think that that's a great point. On the first half of the program, what we're going to be doing is talking about general electronics in our program here. And on the second half of the program, we're going to be getting into a little bit more specifics about computers and technology and the changing world of electronics. Because I know, Dwayne, I have to say to a large degree, I just go and flip on the light switch and don't even think about it. But there's a little bit more to it than just that. Do you find a lot of people just taking for granted the electronics components in their homes?
Oh, most definitely. The fact that you walk over to your light switch in your bedroom in the morning and you flip on the switch, you don't give it a consideration. You don't think about what's behind the delivery of electricity to your home, for instance. It goes right on from that point. You walk out into the kitchen, you take your cup of coffee from the night before, you pop it in the microwave, and you expect it to come out hot. However, there is a lot of electronics technology that is taking place within that microwave oven.
Now, before we're going to get into a little bit more of some of these details, because I want to talk a little bit about the house of the future as we're adding more electrical outlets and more electricity into our homes. But let's talk with Luis a little bit and find out a little bit more about Luis. And Luis, what was it about the Delta College Electronics program that said this is the place you wanted to start your college career?
Well, first of all, the courses are not that expensive like a four-year college is, which that helps somebody that's working part-time and coming full-time to school. That'll help you a little bit. And plus, after a while, you can use those courses to always transfer to a four-year college too.
And I know one of the things we were talking before the show that you're planning on transferring and continuing your education. Once you've completed your coursework here at Delta, what do you plan on majoring on when you go on to a four-year institution?
I'm planning on transferring to Fresno State so I get my electronics technology. I'm on bachelor's.
And one of the things, Dwayne, I guess we can talk a little bit about, as students enter the programs, what are some of the career opportunities that exist for an electronics major here at Delta?
Well, the career opportunities are really vast. It's almost beyond just reciting them to you, because of the fact that everything that you touch now has some kind of a relationship to electronics. Everything from your coffee pot in the morning. Some of you have programmable coffee pots, and you wake up in the morning, the coffee's already made. And it just goes on and on. Such as in your homes, your clothing dryers, your washing machines, they're all microprocessor controlled now. And so you can set them for different types of programs, and they'll go through and they'll do specialized adaptations of the washing cycles to protect different types of clothing. You walk out the front door and you set your alarm on your home. And the alarm system then stays there 24 hours a day, able to watch over your belongings. You step into your car. Before you get in there, you're touching a remote-operated key switch and also turning off your car alarm at the same time. You step into the car.
All right, I'm getting tired already just thinking about all these opportunities. So what you're saying, Dwayne, is that not only can we see our students designing these pieces of equipment, but they also can be repairing them and working on adjusting them to your house situation, a variety of things that go on.
Definitely.
Now, I know you've been in this electronics game for a number of years, over 2 decades. And what are some of the changes that you've seen as you've looked at your classes, the students coming in, as well as the applications of electronics to our daily lives?
Well, I would say that probably one of the biggest changes to the electronics industry is the computer. The computer has brought to the forefront the ability to program predetermined sequences to go through. We find that in our newer homes nowadays, they're coming out completely with interfaces for the computers built into the homes. Not only do we have access to networks, not only in our bedrooms and our kitchens, every room of the house has access to the internet in the newer homes. We, just a few years ago, thought that it was really nice to be able to have cable into 1 or 2 of our rooms in the house. And now, as the newer houses are being built, all of this internet access, as well as, in some cases, ISDN lines, fiber optic communications lines, are being placed in the homes so that you can get the utmost speed and performance from your systems.
Now, Luis, when we start to hear all these opportunities and all these different applications of electronics, when you started to get into this program, what were your thoughts about electronics and electricity? Did you start in high school thinking about this as a career opportunity?
Yes, I did. And I wanted to learn more about the electrons, how they work and everything. And I just found it interesting and everything.
Now, what are some of the initial studies that you had here at Delta? What are some of the courses that you had to take?
The basic, the Introduction to Electronics 11, which is your introduction to DC and AC. Then you have your Electronics 12, which teaches you how your transistors work. Then you go into 13A, which is your integrated circuits. And 14A, your Introduction to Troubleshooting, and 14B, Advanced Troubleshooting.
And what we're going to do is talking a little bit about what Luis has been doing in the classroom. We're going to show you some of the facilities here at Delta College, just to give you a little bit of an idea of some of the things you could expect in the electronics program here at Delta. Dwayne, you might walk us through the lab that we're looking at right now.
Okay, actually what we have is 2 individual labs. One of the labs being primarily directed towards consumer electronics. And in the other adjacent lab, it is primarily addressing computers and computer maintenance, repair, and adaptations. So we have extensive equipment, full working lab station for each of the students to work in pairs. They have a quad trace oscilloscope.
And I noticed that this person is doing some signing in the...
Yes. Yeah, electronics is very well adapted to many of our students who have impairities. The fact that we can bring in interpreters, there is a lot that they can actually do.
And I see that you actually take off the back cover of those situations that we're always instructed, don't take off the back.
Right, and this is one of those natural points for a student when you tell them that they're not supposed to do something, like anybody. It says, do not remove the back cover, no owner serviceable parts. Well, the first thing they want to do is pull the back off. And so we teach them the procedures to go through and how to protect themselves, how to actually go through and do testing and remain safe.
So you could actually, I could learn how to fix my television stuff. This is what you're telling me, is I see this being worked down there, and that becomes...
Oh, yes.
Now, Luis, do you find this an advantage when it's Christmas time and everyone gets some electronic gear and all of a sudden it doesn't work? Do they come to you and ask you for some help?
Oh, yes, they do, especially relatives are the ones, number one, the customers that always come knock on the door.
That's right. And what sort of equipment have you learned to work on?
So far, I learned to work on VCRs, TV sets, and car stereos.
That's terrific. Now, one of the things, I guess, Dwayne, is as we think about some of these consumer electronics, and you know, I am just that sort of basic person where you sit there and you flip on the light switch and you hope it works. But I know there are a lot of hazards that are sitting around my home too that I should be concerned about. As you think about some tips for our audience looking, what are some of the things we should think about from a standpoint of working with electronics around the house?
Well, I think probably one of the most important things for the homeowner as well as the homemaker to be aware of is some of your electric stoves. Quite often we find that in the process of cleaning, you'll remove the heating element, and then you think that you're at liberty to just clean anywhere you'd like. Well, I want to warn people that there's actually still 220 volts lurking around in that stovetop. Also, your oven is another one where you may want to go in to clean the oven. You'll pull out the elements from the oven and then start cleaning in there with a wet rag, and you're playing with a real dangerous situation. With 220 volts available to you in there, and usually the chassis of your oven or your stove is earth grounded, and so as you're leaning on one side and you stick the rag in there with all of the soap suds and so forth on it, you're really at risk. The advice on how to take care of this is to go to your breaker box. And in the breaker box, you will find that there is a stove oven 220 volt switch. You simply flip that to the off position. Then you go in, you turn on your stove to make sure that the lights no longer respond because there's no electricity. Then you are at liberty to clean as well as you wish.
And so, and then it's no problem. I just go back, flip the breaker switch back to on, and no harm, no foul type of thing.
No problem whatsoever. And in fact, with the power off, it's you feel much more comfortable at being careful to see to it that the elements are plugged in properly, because you're not trying to, protect yourself from this electrical hazard.
So more to it than just wearing my rubber-soled shoes to protect me from electricity.
The rubber-soled shoes will help, but if your other hand, such as you're cleaning with your right hand, and your left hand is leaning on the stovetop, you have a direct path through your heart, and
not
this
where
is
you
a real
want it to
hazard.
go. That's right.
It only takes 70 milliamps of current through your heart to cause total paralysis of the heart. Which means your heart stops beating, you stop breathing, and you're on your way out, basically.
That's right. Now, Luis, as you start to think about it sounds like Dwayne stresses a lot of safety in the classroom. What are some of the tips on classroom safety that you've learned about?
Also, not to wear jewelry while you're working with some components, especially on a television. And when you take the back off, you make sure you discharge the high voltage first. And you don't wear no loose clothing, or you don't want something to get stuck on one component and you want to yank on it.
That's great. Some of these things that I had never thought about. I mean, I always worry a little bit whenever I start to unscrew the back of a television set or something like this. Now, are there any courses, Dwayne, for people sitting at home that would think this is a good place for me to start to learn a little bit about household electronics?
Well, yeah, probably if they were to take the introduction to troubleshooting. This is where you learn how to do chassis disassembly, basic measurements of voltages, currents, resistance, and so forth, and the safety, so that you keep your hands off of the things that you should keep your hands off of.
Good things to remember. So what we're going to do is we're going to come back after a couple of brief public service messages, and we're going to be talking a little bit more about computer technology and computer electronics. Stay tuned for some more shocking news about our electronics program.
What's the advantage of using Thevenin's compared to using Kirchhoff's?
It's actually used in conjunction with Kirchhoff's.
Kirchhoff's voltage law and Kirchhoff's current law are totally adhered to throughout the process here. You'll find that we're using Kirchhoff's voltage law on the VTH and the RTH circuitries themselves. What we're doing, though, is we're making the simplification here, and that is a big advantage. By simplifying a complex...
Welcome back to Delta College Impact. I'm Roger Wall, your host for today's program. And on the first half of the show, we're talking about the revolting, shocking news of the electronics program here at Delta College. And joining me on the second half as we continue this discussion are Dwayne Wright. Dwayne is our electronics instructor. And to Dwayne's left is Jonathan Gifford, another one of our electronics students here at Delta College. Dwayne, we sort of left off on household electronics, and on this half of the program, we're going to talk a little bit about computers. Now, I know in the old days, computers used to fill a room, and now we have that same sort of power in a little box that sits on our desk. How have these changes impacted your electronics program?
Well, these computer changes have totally changed the electronics package. The principles are all the same. However, the components have all been miniaturized in our integrated circuits, down to the point where it's almost beyond actually attacking a circuit and trying to understand it on a transistor level. And in fact, the computers themselves have taken on millions of computers into a tiny chip. So the speeds of operation have greatly increased, and in addition to that, the hardware size has been greatly reduced.
Now, one of the things that I've been amazed at is how much smaller everything has gotten. Does that mean the students' hands have to get smaller, or how do you actually repair all this stuff because it's so small and compressed?
Yeah, in many cases, they do have to have smaller hands. And in fact, I've been dealing with some different companies that are doing camera repair for the video cameras, and they're hiring the ladies as technicians to come in because of their ability to hold smaller components, to work with tweezers rather than with a monkey wrench, and be able to pick up these components and actually set them down on the board and do the hot air soldering that is necessary to do board repairs on the video cameras.
So my repair work with a hammer is sort of passé these days, I guess.
Yeah, the hammer work is only the last resort.
Now, Jonathan, I know one of the things that we had talked about in the first half of the program is what gets a student involved in this program. What was it that made you say, hey, electronics is right for you?
Well, I had actually started out many years ago, long before I was ever ready to go to college or high school for that matter, tinkering and pulling things apart. And we've had a computer in our home. In fact, we even had one of the original Macintosh computers in our home, and so I worked with that for years and progressed with the market there. And as I got into it, I thought, well, that's something I'm really interested in, something I'd like to pursue. And Delta looked like it had a very good program, and it fit well within budget, and it was classes that you could go to, and they were hands-on, practical, not a lot of the out there in another world. So that's kind of what got me into it.
So it actually was the stuff that you could get into and work on. And I know in our computer lab, do you have the students actually working on computers?
Yes, the majority of the work that they do in the computers, however, is through the IBM type computer, the IBM clones. And we find that we have a ready supply of equipment for them to work on due to the fact of computers making their technological advances. And as the computers at a company become outdated, so to speak, for that company's application, they're still very much in vogue as far as training is concerned. The principles are all remaining pretty much the same, and the technologies are pretty much the same. It's just the speeds that are increasing. Mm-hmm. And so we find ourselves quite fortunate in getting ample equipment for building up systems. In most cases, the students go through, they have opportunity to build up a number of different computer systems.
Well, what we're going to do now is we're going to take a look at one of those computer labs here on the Delta campus and give you a little bit of an idea of some of this type of equipment that Jonathan works on and that Dwayne teaches about. So Dwayne, you might have us walk through a little bit of this lab, and what are we looking at?
Okay, this is our computer side of our lab, and you'll find that at each one of our workstations we do have an IBM clone type computer, and within the use of those computers we actually will have software that is available for them to simulate their electronic circuits. By simulation, it allows them to go in there and experiment with things, change values, and see the interaction of the components as it is demonstrated on the screen. The computer itself has simulation of an oscilloscope, multi-processor. It has a signal generator, multimeter, and all of the standard types of test equipment that can be simulated. Then as they move out and start making circuits on the, we build them up generally on a protoboard first for them to experiment with them, and then they can readily have available to them all of the test equipment that is necessary in the actual equipment, going beyond the simulation. So it gives a real well-rounded approach to learning electronics and being able to do individual experimentation.
Now, Jonathan, I think I saw you in that picture there as you were starting to work on taking a look at inside of a computer. What are some of the things that you have picked up as you've gotten more into the IBM computer and such?
Well, basically, I mean, some of the standard things that you do are, you know, there's modems that are installed, CD-ROMs, floppy drives, things that go out that you have to replace. And so basically, there's a lot of going in there and finding out, you know, how you test the equipment. And normally, it's easier to have two computers, one that you know is working, and just to swap out the equipment until you find where the missing link is. But it's a lot of just getting down there, and then after working with it, you start recognizing, oh yeah, this would cause this and that sort of thing, you know. And half the time, it's because the battery on the motherboard has gone down or something. It's, you know, causing some problems. So.
And I noticed, Dwayne, as we look at it, that the students are working with calculators, and so what it says is that a lot of students, you need some prerequisites as well. You don't just take the electronics courses. What are some of the other courses a student would be expected to take here at Delta?
Well, we do have some requirements for some math to be taken along with the program. Generally, algebra is a minimum of a requirement, and they do need to have good reading skills, because the majority of the information that you're going to be using for troubleshooting is available in written form. Now with the easy access of the internet, we find that we can get extensive information from the manufacturers. We can simply get on the internet, call up their website. We can search using their search engines on the websites to actually find documentation for components that we might have been waiting weeks to get. Mm-hmm. We simply download it. Of course, again, they still have to read it, and they have to understand, and actually that is part of the program that we teach, is how to understand the documentation and the symbologies that are used within the training program.
Now, one of the things I think we should clarify right away is we have a computer science department here at Delta College that talks a little bit about software, and the other side of the coin is hardware. And maybe you can differentiate for our audience and myself, what's the difference between that software and hardware, and how do you get involved with the computer versus how they're involved with the computer?
Okay, in the computer science area, they primarily will deal with the software packages and how to interact with those software packages, causing them to be perhaps altered in a way that's going to fit into a particular business situation or into an application of scientific areas. In the electronics department, what we try to do is we look at the computer in a whole different way. When we look at the computer, we look at it with the case open. We see the monitor with the back off. You know, we see the cables with the shrouds taken off and the actual pin connections. This gives us a whole different approach to the computer, understanding how the computer relates one piece to another. And in fact, in our digital class, what we do is we build up what is comparable to a mock-up of a microprocessor chip, to where the students actually will build on a protoboard and in simulation. They will build many of the functions that are going to be characteristic to most of your microprocessors.
That's great.
So as this takes place, then as they approach the microprocessor and the microcomputer, it's not such a magic box type of an application, but rather it is data buses, it is tri-state devices, it is memory modules, it is registers, it is shift registers, and the list goes on and on.
That sounds great. You know, from my standpoint, it's still a mystery box, but it's great to know that somebody understands this. Now, Jonathan, as you look down the road, where do you see this coursework leading you as far as your future?
Well, basically, where I'm going with it right now is pretty much has been as a tech. In fact, I'm doing that currently kind of part-time while I'm finishing out my program this semester. And so tech work is mainly what I've been doing. And it's a lot of fun. It pays very well, and you get to work with a lot of different people. And half the time they think, wow, this is so neat, you understand this thing. And, and it's just a matter of knowing how it works inside, and you realize it's not that difficult. It's just you have to comprehend what's going on.
And I know that technician stuff is very valuable. And for those of you in the audience who might like to learn more about our electronics program here at Delta College, we're going to give the address and telephone number of somebody who's going to be able to help you out as you start to think about a future in electronics here at Delta College. So if you would like to contact Dwayne Wright, here our electronics instructor, you can contact him at 954-5230 or write him a care of our Applied Science and Technology Department at Delta College, 5151 Pacific Avenue here in Stockton, zip code 95207. Well, I'll tell you what, I'm feeling a little bit better, even though I should tell you that I am not going to take the back off my TV set, and I'm not going to unscrew my computer, but I'm going to try to get it to people such as you guys, and to make sure that they're trained through Delta College. And so one of the things, Dwayne, I want to thank you for joining us, and Jonathan, thank you, and best of luck in your future. And I want to thank all of you for watching, and we want to encourage you to watch your future Delta College Impact and learn a little bit more about Delta College and a lot more about what the future might hold for all of us. Thanks for watching.